Hello there, Nareg is here. Today I'm going to solve the second exercise from first session 2016 chemistry, which is related to electrochemistry. So let's start second exercise, functioning of a galvanic cell. A galvanic cell is a device that converts chemical energy into electrical energy due to a spontaneous redox reaction. The adjacent schema represents a functioning galvanic cell. Label the numbered parts 1 and 2 of the galvanic cell. So the number 1 is actually a strip which is immersed in Fe2+, while the strip number 2 is immersed in Cu2+. In order to have a functioning cell, galvanic cell, you need to immerse Fe strip, an iron strip, in a solution containing Fe2+, and a copper strip in a solution containing Cu2+. So 1 will be iron strip, As for 2, it will be copper strip. Indicate the anode of the above galvanic cell, justify. Now, in order to find out which strip is the anode, we need to check the schema so we can find out the electrons. The orientation of the electrons is from strip 1 towards strip 2. So the strip 1 is losing electrons. Since it's losing electrons, so it means that there is an oxidation which is going on, and then it is the anode. So the iron strip is the anode. Iron strip is the anode. Now another indicator is when you check the strip of iron who has become thin. As for the copper strip, it has become larger. So it means that iron strip is losing electrons, plus it is being converted to Fe2+ due to the oxidation. So this is another indicator that iron strip is the anode. Write the half reaction that takes place at the anode. Since it's the anode, we have an oxidation reaction. So this oxidation will be CFe being converted to Fe2+ plus 2 electrons. The equation of the overall redox reaction of the functioning galvanic cell is Fe plus Cu2+, which gives us Fe2+ plus Cu. Deduce the half reaction that takes place at the cathode. So we already know that Fe is being converted to Fe2+. So the reaction that is going on at the cathode, it's a reduction. Now this reduction is Cu2+ plus 2 electrons being converted to Cu. During the functioning of the cell, the quantity of Fe2+ iron varies in solution A. Compare the amount of Fe2+ ions in solution A before and after the functioning of the galvanic cell. Now, before the functioning of the cell, let's say we had a certain amount of Fe2+, let's call it X. After the functioning of the cell, we have the oxidation that is going on at the anode. So this oxidation will generate Fe2+. So the quantity of Fe2+ will increase. It will be greater than its initial quantity, which we already said it's X, so it will be greater. That's why we can say that before and after the functioning of the cell, the Fe2+, the quantity of Fe2+ is increasing. Specify the ions that migrate from the salt bridge toward solution A to maintain its electroneutrality. So in solution A, which is the anodic part, we have Fe2+, which is increasing, just like we said previously. Fe2+ is increasing, the positive charges are increasing. We need negative charges to have a certain balance in order to have this, in order to maintain the electroneutrality. So the ions which are NO3- will migrate towards the part where the oxidation is taking place. Um, that's all for this second exercise, session 1, 2016 chemistry. I hope it was helpful. So I'm gonna ask you to subscribe to my channel because I'll be uploading new material. I'll be solving new sessions, so you'll be notified. And I can also share with you my Instagram, Facebook account. You can contact me directly or you can simply leave a comment below. That's all for this time and see you later.